Smart question. Okay, so we're gonna, like I said, we're gonna start some basic trigonometry. I want to give you a little overview of what's going to be involved with this. You see, every time we have a right triangle, we're going to have certain sides on it and angles. So here's a nice big right triangle that I've drawn. And I'm going to label these sides like we do in geometry. We call this A, B, and C. Now, we usually use capital letters when we're talking about the vertices. The vertices are right here. Okay? Those are called the vertices of a triangle. Now pay attention. Everybody needs to pay attention. The corners? The corners. Yeah, the corners are the vertices. Now, you have to learn how to name the sides correctly. Now, on the sides, we're going to use lowercase letters, okay? Now, I'm going to say little a goes here. I'm going to say little b goes here. I'm going to put little c over here. Now, the question is why? Okay, so it's a good question. So, yeah, now here's the thing. You see, imagine this is an angle. Okay, right here, there's an angle kind of going like this. Now, the way I like to think of it, I'm sharing with you guys secrets now, so I want you paying attention. Imagine this is some eyeball looking this way. When the eye is looking at this side over here, it's always looking at the opposite side. So from this perspective, from angle C, this would be the opposite side. Okay? And so the little letter goes opposite of the angle. You see, so if this were an eyeball, or looking this way, its opposite side is over here. And so the little letter that goes with the angle, it goes with the opposite. It's on the opposite side of the angle. Okay? And then this one goes over here. So that's kind of how we put the letters in there, just so you know. Now, we also need to talk about what's called an adjacent side. So we have three sides of a triangle. We have what's called the opposite side, opposite. We also have what's called an adjacent side, adjacent. And adjacent means like next to, next to. It's like a neighbor, okay, like next to, next door neighbor. You know, that's how we describe it, adjacent. And then we have also the hypotenuse. Now, it gets a little bit tricky when we do some trigonometry because you're going to have to identify these three sides of a triangle. And they sometimes change. So let me show you something here. Now I need the talking to stop. So, okay, so I need to clean this up. Now. Okay, so like I said, with respect to angle C, now notice I'm saying with respect to angle C right now. With respect to angle C, this side over here is the opposite side. Now, by the way, we're going to start abbreviating because mathematicians are like lazy. We don't like to write out the whole word every time. So we're going to abbreviate these three words by using the first three letters, okay? Opposite, adjacent, hypotenuse. Now, the hypotenuse is always easy to identify because the hypotenuse is always opposite of the right angle. And it's always the longest side of the triangle. So this one is the hypotenuse. So do you see, we know where the opposite side is? It's over here. The hypotenuse is here. That means the adjacent is here. Okay? Now, this is with respect to angle C. And so what we would do is put adjacent here. Adjacent. Now I want to give you another little hint about the adjacent side. it's not necessarily the smallest side, but that's a good idea. But here's what you can say. It always touches. It always touches the vertex. Does that make sense? Now the opposite side doesn't really touch. You see, because there's your angle, right? Angle C. Its opposite side is over here. The opposite side doesn't really touch the angle, but the adjacent side does touch the angle right here. You see, it extends from this vertex going over this way. You see, you kind of see that? So you can always tell which one's the adjacent side by that little idea there. Opposite side is over here. You're looking at it. The hypotenuse is always the longest side. Now here's where it gets tricky. I'm going to do the different color now on purpose. Angle blue. Now, if we're talking about angle A, then we got to label things a little bit differently. Because in this case, angle A is looking at this side over here and saying, hey, that's not the adjacent side. That's the opposite side over there. You see? So from A's perspective, this is the opposite side. Okay, now the hypotenuse is the same because that's always the long side. But from angles A's perspective, this is no longer the opposite side. Remember, the adjacent side touches. It touches. So this side comes out this way and it's coming down this way, right? And there's my big arrow. It's coming down this way. So A touches this side over here. So this is the adjacent side. This makes trigonometry a little bit confusing because in some cases it will be the opposite side here. In some cases it'll be the adjacent side. In some cases this will be the opposite side. Sometimes it'll be the adjacent side. Now the hypotenuse is always easy. The hypotenuse is always the hypotenuse. Okay? So the way you decide is that we need to decide which angle are we talking about, this one or this one. Okay? Now when we're doing trigonometry, we don't care about this one. The only thing we care about this one is that we have a right angle. That one is always a right angle there. It needs to be a 90-degree angle, okay? Well, that kind of gives you a little bit of an overview on how to label triangles and stuff. And now we're going to go through our PowerPoint a little bit slower and talk about the tangent ratio, okay? So here's my cool PowerPoint I made for you guys. Apply the tangent ratio. How about that? Looks kind of cool. You've never seen this one before, right? Yeah, new. Did you see? Okay, objective and essential question. Those of you taking Cornell notes, you're welcome to fill out the objective. This stands for students will be able to apply the tangent ratio to find the length of a right triangle. Essential question, how can you find the leg of a right triangle when you know the other leg and one acute angle? So we're going to find out. There's really cool stuff we're going to do here. Okay, so there's a little activity you can do sometimes. And if you have time at home, you might take a ruler and you might try this out. Like for example, yeah, what you do is you start out by drawing a side here and you create an angle going like this. Imagine that's a straight line. And what you're going to do is measure this length and then you're going to divide by that length. It's like you divide the two lengths. So this might be A, this might be B. And so then you figure out, well, what does A over B equal? Okay. And then you take a look and you measure that. And let's say you measure that and you go, oh, well, that's about 7 centimeters. Okay. And you measure this one and you go, oh, well, that's about 5 centimeters. 5 centimeters. And 5 centimeters like that. So then when you divide these two, you get like 7 over 5. Okay, does that make sense? Now, what's kind of interesting, this is really fascinating. I don't know if you've ever done this before. But if you measure this length now, okay, it's going to have the same exact ratio that you had before. If you measure those two. Like, for example, this length here might be 14, and that length there might be 10. Okay? And when you divide this, you get 7 over 5 again. And that happens on any triangle that you do. If you continue this outward farther and farther. Kind of an interesting experiment. And And so what we're building up to is what's called the tangent ratio. A tangent ratio. We're getting to that. So let's go back to the PowerPoint. Take a look. Anyhow, when you do this scenario and you measure all this, you start to realize, hey, I'm always getting the same ratio. So that gives us a conclusion. The ratio of the opposite leg to the adjacent leg is a constant. No matter what, I divide the same two numbers, I will always get the same number. And this happens for any angle. That's what's kind of surprising. It happens for any angle. Okay, so just read the following here. A trigonometric ratio is the ratio of length of two sides in a right triangle. You will use trigonometric ratios to find the measure of a side or an acute angle. Now, this might be tricky at first, but after we do 4 or 5 problems, you'll get the hang of it. Pretty easy stuff. Okay, so we will be abbreviating. Like I said, opposite, adjacent. We'll also have the hypotenuse in there. And when we start talking about our trig functions, we'll start abbreviating them also. So the way that we're going to abbreviate, we have 3 trig functions. We have one called the tangent, and we're going to abbreviate that one by writing tan. We have another one that's called the sine. And funny, we write that one and we write this one as sin. Except for we pronounce it as sine instead of sin. Okay? And then we have another one that's called cosine. This one's called cosine. And we call this one cos. We actually call it cosine. Okay? So tangent, sine, cosine. Those are the 3 big trig functions that we're going to be talking about. And like I said, we're going to be just covering the basics because they're related to triangles, and typically triangles are a geometric idea. So we're studying some properties of triangles. And so let's continue. Go to here. So the tangent ratio. Now again, this is where it's tricky, and we're going to practice this quite a bit. From A's perspective, the tangent would be the opposite side. Well, that makes this one the opposite side. Remember, A is looking at the opposite side. Whichever angle you're dealing with, the side that it's looking at, if you imagine it's an eyeball, it would be always looking at the opposite side. Okay, so with respect to A, the opposite side is over here, and this one would be the adjacent side. Remember what I said? The adjacent side is always touching the angle. There, it touches right there. Bam. So this side touches. And as we move along this way. Now, the easy one to figure out is the hypotenuse. The hypotenuse is always on the longest side of a triangle. Make sense? Okay, so let's look at this. The tangent of A. So what we're talking about here, this is kind of new notation. The tangent of this angle is going to be equal to the length of the opposite side divided by the adjacent side. Okay, so this will make more sense once we do some examples. Here's some practice. Okay, you ready for this? Alright, and then we'll do some of your study guide. Okay, so we want to talk about the tangent of S and the tangent of R. Okay? By the way, you're going to need a calculator for this. So, yeah, do you want to pass these out to each person? Give each student a... Okay, so we're going to start off with the tangent of S. The tangent of S is equal to the opposite side over the adjacent side. Okay? Well, remember how to identify the opposite side. Imagine this is the eye. This is my angle S I'm dealing with right now. The opposite side with respect to S is over here. So that's the opposite side. The adjacent side would be this one because it touches the angle. It touches. So this side would be the adjacent side. So if we wanted to find the tangent, it's equal to the opposite side over the adjacent. So in this case, it's equal to 80 divided by 18. So do this in your calculator and see if you get the same answer I get. The tangent of S is going to be AT divided by 18. I get 4.4. Is this the answer they want? What do they want? They want to, hold up, write the answer of each fraction and use the decimal to 4 decimal places. So they don't want that. They want to keep going here. 4, 4, 4. Is that the answer we want?
No.
Yes, that is. That's 4 decimal places right there. So there's your answer for this one. Make sense? They want to go 4 decimal places and then stop. Okay, now I'm going to use a different color pen to illustrate what is the tangent of R. Okay, so once again, it's equal to the opposite side over adjacent. So the question is, why can't I use these two numbers again? I can't because now I'm dealing with this angle over here. And this angle is looking at which side over here? It's looking at the opposite side over here. So from blue's perspective, or from R's perspective, that is not the adjacent side. That's the opposite side over there. And then this side, remember I said the adjacent side touches angle. So this is not the opposite side according to R. He says it's the adjacent side. So from R's perspective, you got to take 18 and divide by 80. Does that make sense? And when you do this one, we get, what do we get? 18 divided by 80. We get 0.225. Is that the answer they want? No, they want 4 decimal places. How do we fix that? Yeah, just add a 0 right here. There you go. You can add zeros onto the right, okay? And it's still correct. Okay, so that's how they want us to do tangent S and tangent R. You think you can try it now? You want to try it on our study guide? All right, so do me a favor. If you have your study guide, want you to try numbers 1 and 2. Numbers 1 and 2 on your study guide. I'm going to pause the the recording. Okay, so we finished up the first 2, right? Okay, now let's move on to a slightly harder problem. Let's try this one now. Now, erase the board for you. Now, we start out the same way. Except for now we're dealing with this angle right down here. We're dealing with this angle. Why do I have this angle? Okay, this angle. With respect to this angle, I'm looking at the opposite side. So this one is the opposite side, right? And this side is the adjacent side. You guys all good with that? Okay, so what we do is you write out the same exact expression again. This time tangent of 32 degrees. 32 degrees. That's that angle right there. It's equal to the opposite side, 11, divided by the adjacent side, which is x. Okay, so now we're going to start solving algebraic equations. Now, this you can put into your calculator. And you'll notice on your calculator, you'll have a button that says TAN. TAN. Does that make sense? You guys see there's a button right in the middle of your calculator. It says TAN. What you want to do is hit the 32 degrees first, or hit the tangent button. Hit the tangent button and then hit the 32 degrees. and then hit enter. Now, hopefully what you have right now is 0.6248, and you'll notice it goes on forever, right? In fact, for our purposes, guys, pay attention so you get this right. Anytime you put this in the calculator, let's just go to 2 decimal places, okay? Or 3. 2 or 3 decimal places, depending on what you want. 2 or 3 decimal places. Okay, you don't have to go clear on out to 15 decimal places, okay? So I think for this problem, I'm going to go out 3 decimal places. Alright, so if I'm going out to 3 decimal places, then I need to change this one to 5, right? I'm going to call it 0.625. Now that's equal to 11 over x. Now do you know how to solve for x in this case? If you're good at algebra, you can solve this, right? But here's what I recommend. Write this over 1. Now do you know what to do? Cross multiply, right? So now you cross multiply this way, cross multiply this way. And if you take x and multiply by that, you get 0.625 x. And then 1 times 11 is 11. And now what do? Now we divide this side by 0.625. And we divide this side by 0.625. And this cancels off. And we get x is equal to 11 divided by 0.625. And I get 17.6. Does that make sense what we did? It's kind of a handy tool because you can use trigonometry to measure the height of a telephone pole, for example. If you use some basic trigonometry, that's what you can do. You can measure the height of trees. You can measure the height of buildings. Any questions? Okay, let's try another one. Alright, let's try this one. Okay, so I want to give you about a minute to do this, but you can try to set up the equation. Start out by labeling your sides. Like, this is my eyeball, I'm looking this way. So you want to identify what you have. This is the opposite side then. And this is the adjacent side. Okay? So yeah, try to do this one if you can. It's just like the last one. And then we'll do a couple problems on your study guide. Alright, let's see if you guys get the same answer I got. Okay. I say that the tangent of 17 degrees, it's equal to the opposite side. Well, in this case, the opposite side is 9. And the adjacent side is x. I'm going to divide by x. Remember, it should be opposite over adjacent. Right? So now I plug this into my calculator. And I'm going to go 3 decimal places. 306. And remember how to solve this? You can just write this over 1 and then cross multiply. Okay, so I cross multiply this way. I get 0.306 times x is equal to 9. Now I divide this side by 0.306. Divide this side by 0.306. And I get x is equal to I get 29. I'm going to go to one decimal place on my final answer, 29.4. Does that work? Yeah. Isn't trigonometry kind of cool? Now, the reason why we have trigonometry is because most triangles are not those special ones we had. Remember the other day, section 7.4? When we had 7.4, we found out how to do these. If it's 45, 45, 90, like right here, and this one's 45, and this is a 90-degree angle, remember, we know how to do that now. This one we can do a square root 2, right? And we have another special triangle, okay? If this is 30 degrees here, and this is 60 degrees, and that's a right angle there, then I know the ratios for this one. A square root 3, and 2a. That's what we were doing on 7.4, right? But what do we do if that's not a 45, 45, 90 or a 30, 60, 90? That's where we have to start doing trigonometry. Does that make sense? So that's part of the reason why we're doing this. And so now let's go back to our PowerPoint. We did this one. And so now you kind of understand how to do it. You just use the tangent ratio. If you have the opposite leg or the adjacent leg, you can find the other one by using the tangent ratio. Okay, so what I would like you to do now is finish up your study guide. We will save the book assignment for Monday, okay? And this is where we're going to stop.